So yes, I'm from Simon Fraser University as well, and I'm a postdoctorate researcher there right now. And what I will be talking about today is my PhD research and my PhD journey, which I created an embodied conversational agent, which was showing empathetic emotions, that is to reflect what the user's emotions are by its speech and by its facial gestures and bodily gestures and so on and so forth. Of course, the PhD research itself is very extensive, but thank you. To start, I wanted to give you like the bare bones implementation and how you can improve it if you really want to get your hands dirty and if you're really interested in embodied conversational agents. And I'm not sure how much of you here knows what embodied conversational agents are. Do you guys have an idea? Okay. So what I will do is first explain what they are, and within the 25 minutes, I will go over the components of my system, and as it consists of a behavior realizer, some processes to how to process the input, how to do decision making over those inputs, and how do I output the behaviors of my agent. And this is what an embodied conversational agent might sound like. You're seeing the examples of ECAs, or embodied conversational agents, that our lab is using. And these are agents that can interact with the users with a multimodal, situated, and real-time interaction to emulate a similar experience to human conversation. So the idea is how we can create an agent who acts naturally, natural enough, and social enough, so you have the suspension of disbelief for a moment, then you actually think, okay, you can actually conversate as if you're talking to a human being. And these agents can take on the roles of educators, assistants, and even companions. In my PhD work, I was focusing on how we can assess depression in people, and if we can help it throughout the conversation. But the initial input for these agents are often in the form of speech or video or both, but it can also be other biosignals such as heart rate, EEG, skin conductance, and so on that are received from the user. And for my work, I was only using the standard webcam and the microphone setup. But as for outputs, you have the multimodal behavior from the agent. So it is the speech of the agent, the gestures, the body shifts, even the gaze. We have a postdoc that's working on the breathing patterns of the agent, so you can really go crazy with it. And this is a lot of work if you do it from scratch, because you not only have to process the inputs and reason with how to give a response to the agent, but you also have to build the model itself, like the 3D agent, and you also have to get the animation. So the avatar does this gesture when I actually want it to do that gesture, and how this gesture blends in with the other gesture. So you kind of have to figure out all those processes within your system. And these behaviors also has to be synchronized. But lucky for us, there are open source tools available that we don't have to go through all the hassle of creating an agent, creating the graphics and animations engine. So we can only work with the core components, and they are called behavior realizers. So the behavior realizer I was using for my PhD was called SmartBody, which is from University of Southern California, which we are very in close collaboration with. And it has ready agents, 3D agents, and ready 3D animated behaviors that are synchronized, that you can just plug in your AI logic, like get your pipeline in and use this as a endpoint so that you have this animated gestures. And it is open source and written in C, and it can be incorporated in most game simulation engines such as Unity, Unreal. And there are also a lot of other behavior realizers, as well as the one we are currently working on in our lab, in Iva's lab and SFU. And Procheta is one of our master students sitting there. She is one of the leads of that project that we are doing the 3D model creation, rigging, and the behavior synchronization for that. Oh, sorry. So the only thing you need as an input for such a behavior realizer is a message called behavior markup language. So what does it look like is this. This is an example of BML or behavior markup language message. It is a standard way to represent a behavior block for your 3D agent. So this whole BML message is one huge behavior block, which has 3 behaviors in it. One of is the speech of the agent, the other is the gesture, and the third one is the face of the a facial gesture. So you can see the speech of the agent right now is, "My morning started off amazing." And the gesture with it is a gesture called beat low, which is one of the standard gestures of like speaking. Beats are called these gestures. And the facial gesture is 102, which I know is a happy gesture. And they have all these different kind of facial gestures you can play with. And the third thing you need to be aware here is all of these gestures has a synchronization constraint, which I say that my gesture of beat will start when the speech hits T4, which is amazing. And my facial expression will go through from the start of the speech to the end. And that's the only constraint I have to give to the system. And if you pass such a BML message, what the behavior realizer will be doing is actually playing it. I hope this will do it. Okay, the sound doesn't work, but here it just says, "My morning started off amazing," and it just does the gesture. Yeah, sure. Okay.
My morning started off amazing.
So yeah, when you send this BML, it does it automatically, so you don't have to do it. And I mean, it takes care of the behavior and the synchronization once you determine what to do. So since we have the behavior realizer taking care of the final BML message, all you need to do is to figure out how the framework to create this message in response to user actions, which will require how to process the inputs, decide the actions, and prepare that BML message. Easy, right? Well, not really. For my whole PhD, I was kind of working on this. And I created a framework specially to model empathy behavior in my embodied conversational agent that takes the facial gestures and the speech of the agent and processes them in a perceptual module and sends the information to a controller for decision making, and then prepares the multimodal behavior expressed by our agent. And we don't have enough time to go into much in detail of the framework itself, but it is readily available at GitHub, and it is written in Python 3.5, and it also supports 6 and 7, and you can deploy it in a Windows platform. But what I will do is instead focus on each component and explain to you how you can create like a bare bones agent and for like a similar type of framework. So let's start with perceptual capabilities. What I had in my system was speech recognition as well as emotion recognition from the voice, face, and the speech text of the user. For starting with a simple version, I will focus on only 2 of them, which is the speech recognition and facial emotion recognition. So for speech recognition, I have used the speech recognition library in Python. It's just called that, and there's the link. I hope you can see, yeah. We support several APIs as well as local open source speech recognizer from Carnegie Mellon University, which is called Sphinx. It's not the Sphinx that you guys are using, but in my system, I didn't want to be dependent on like a API that will go into the cloud and do these calls, and which I will have to pay for it at some point. So I wanted to have the local speech recognizer. That's why I chose Sphinx as a starting point. But unfortunately, the readily available models of Sphinx was not very good with my not native accent, or I don't know, high-pitched voice, I guess. And we have a very culturally mixed lab, so none of the people were able to conversate with it well. So in the end, I decided to use the Google API, and well, but you can also use the Microsoft API for which is supported by the speech recognition library. And there are many data sets which I didn't have much time to, because I was working on the decision-making component mostly, but there are many, many data sets such as LibreSpeech, Speech Command, VoxForce, that you can actually train your models with, so it's pretty handy. No, this is just for speech recognition. So it has audio like files, and the description of what is in the audio file, so you can train it. Yes. So yeah, that was what I was doing in my PhD basically. The empathy engine was supposed to be understanding whether the person is in distress, and if so, providing coping mechanisms, which is like it was doing it by doing mimicry when you are speaking. So if you are sad, it was just matching it, and if it was getting the emotional value of your speech as a whole. And when it was answering you with its dialogue, it was taking like into account of that emotional value of the speech. Huh? Emotional? I didn't. Yeah. Yeah, sure. And yeah, so we came to the facial emotion recognition part. Because we want to know what our user is feeling and we want to connect with it. I wanted to have this facial emotion recognition. For this, I trained a convolutional neural network using Keras with a TensorFlow backend, and using the John Kennedy, the first data set, is a very well-used data set for it, which you can find in my GitHub page. And there's another tool I really like that is called OpenFace, which is also a Python and Torch implementation. And if you're really interested in those, you can go ahead and play with it. And so after just these two simple steps, what we can have is the text of the speech from the simple audio file, so the text of the user, and the facial emotion of the user. So we can directly match the emotions of the user when it's talking. I also have the head nods here for listener feedback. And in the end, just by using these two simple components, you can have an echo bot that just basically repeats what you're saying after listening to you. But it is this is what I call the bare bones. Like this, if you start with the system and start putting more and more decision-making capabilities, you can build up you can build up a more smart system, more smarter agent actually. Yes, you can actually download this and start using from this EchoBot. You don't have to really do anything except downloading SmartBuddy with it. And next, if we want our agent to be a bit more than a parrot, we want to give it more smarts to actually reason with what you're saying. And that's where the controller model becomes more important, where I was talking about the empathy mechanisms part, which is here, but one of the most important components of this module is the dialogue manager, which is actually getting the text from the user and preparing a response for it. And it is also good if it allows a little bit of flexibility in turn taking, which is a huge issue in the dialogue management literature. But for this talk, I will only focus on adding a bare bones dialogue manager, which can be improved later, easily later on. So the dialogue management literature is actually quite extensive, but this is a very, very simplified representation of a goal-oriented and user-initiated conversational system. So let's say we want our awesome agent to be able to answer questions about weather for some reason. And what this module does is getting the user input, which we grabbed from the speech recognizer, which is what is the weather tomorrow, and extract the relevant information from it using its natural language understanding tools. So the relevant input from this will be the intent. So it will categorize the input of the user as, okay, the user is asking about weather. And the second information which is relevant is the entity, which is the tomorrow. So user is asking about the weather, but user is asking about the weather tomorrow. So what this model does is trying to assign the dialogue a state and saying, we are in the state of retrieving weather information, but the only information we have about that is that the user asking about tomorrow, but we still don't know what the location is. So the dialogue manager, what does dialogue manager decides is, okay, I have this information missing, so I have to go to my database and find a way for asking the user to retrieve that data from them. And this is what it does. It goes to the dialogue response selection, which is I need to ask about the location. And from its natural language generation model, it says, okay, where are you based? And you can keep this cycle going on as much as you want until you fill all the slots. This is called slot filling. And then you can create this more responsive agent rather than just repeating what you said. And for this, my favorite open source tool for dialogue management is Rasa, which is an open source tool that can be deployed on your in your computer. Going back to the dilemma I had between having a speech recognizer from working in a cloud API versus in my local machine. I had my own dialogue system because I was interested in a special case of dialogue, which I said was how to give empathetic information. I was working on a survey conducting agent, but there are many, many different systems. There are good starting points to understand how the dialogue management works and get your hands dirty, which I think you should never be afraid of doing. And there are many open source datasets as well. Even though I put only one link here, this is a really amazing link. They have lots of datasets for different types of purposes. So you can create a still goal-oriented system, or what they call as an end-to-end system, where you have a database of questions and answers, for example, response pairs, which you can train together rather than having this entity slot filling and so on and so forth. Yes. Yeah. So Crocetta was actually using that. She's working on this VR companion assistant, and when she was doing that, she was using the Watson, the IBM assistant. Yeah. Okay. Okay. And yeah, after you add that component too in your pipeline, that what you will have is a more properly responsive agent with just adding just one AI component, which is actually not super smart, but it changes the responsiveness of the agent by a lot. And you will still get the inputs, but you will add a reasoning step before preparing the output. And hopefully, this is what I...
How often have you had trouble falling or staying asleep or sleeping?
A lot. I'm having trouble falling asleep.
Sorry to hear that. Try to lower your caffeine intake, or try not to use any electronic device at least 1 hour before going to sleep.
Okay.
How often have you been feeling tired or low energy?
A lot. Almost every day, even.
I'm sorry. It's going to get better. This might be due to the changes in the weather. 20 minutes exercises a day might help you on this.
Yeah, I'll try.
So this was a
Thank you so
simple
much for taking the survey.
logic where they call the waterfall, because I had to go through the...
Like you might use a little help in general.
Sorry.
Try to make an appointment with the Student Counseling Services at SFU.
What it was doing is it was going through this survey, and depending on the answers I was giving, it was asking more and more severe questions about my depression. And in the end, from all the questions, it was calculating a score for my depression score. And in the end, it was deciding, okay, this is really severe. You have to go to the counseling service, or like, you're fine. You just go and play with your friends. Or this is actually the survey that the SFU counseling was using. And we were trying to understand if the students were using such a embodied agent, would they be more like happy to interact? Because like it was a paper-based system, so you were actually going there and answering all these questions and handing over the paper. And like we were trying to improve that part to make it more a natural interaction. But yeah, so all these elements should be enough for you to get an initial implementation and improve over time. Especially if you want to start with the EchoBot, it's a really great way to like test your skills and play with your agent. At first, I really had an agent for myself that was recognizing my face and giving nice comments to me, but giving shitty comments to everybody else. So you can just do and go crazy, do whatever you want. But yeah. There are a lot of ways to improve such a system. And if you really want to play, and Vancouver has a lot of rainy days, and if you're stuck in the house, so you can go and improve your dialogue. I had an audio emotion recognition as well, so you can play with that. And that's the data set, which is where like everybody is using that one. And analysis for the text you get from the user, which I used extensively. So yeah, these are the several ways that you can improve. And I know there has been a lot of links, but maybe I can share it with you guys and you don't have to take pictures. I was seeing a lot of people taking pictures all the time. So yeah, thank you. And any questions? So the question is, if I understand it correctly, what was the data set for the audio data set? So that was just for the speech recognition part. What it had is just the audio samples and the description of the script that was inside the audio sample. So it is usually either a huge sample that has like the whole sentence, or small words as like a small chunks of the sentence set by a different people. But for example, there was one LibriVox dataset, which is an audiobook dataset. So what you have is one file for the entire book and like the contents of the book itself. So you can train it on it and you can match. Oh, yeah. So the question was, if you had an input that wasn't in the data set, how was it lead you to the correct one? So what it does is if you train it in a speech recognizer, it will give you a confidence interval. So it will say, I think what this person said might be 65% this and 35% that. And then from that, you can either decide, okay, I'm not going to take anything below 60%, or you can make a system that actually asks the user, which is actually the best way to do. And, oh, did you meant this? And if you get a confirmation, that you can move on. So for each of the systems I was using, a different kind of algorithm. So this is like a general overlook for what I was using for every part. So this face recognition, I was using OpenCV and CNN, which is the algorithm I was using. And for audio recognition, CNN is still the best version, was it? But for the language part, I was using natural language toolkit. And there are two sentiment, because I was working mostly on the emotional part of it. There's the so-called so-called sentiment analyzer, which is also open source system from SFU, which kind of takes the grammar into account as well as the natural language components, the input that you get from the natural language toolkit. And there is also another library I was using, which is Wader. It gets the positivity and negativity of your sentence rather than saying, okay, this is a happy or sad word. For the whole project, so that is a bit difficult to say because as you see, my project has a lot of different components in it. But for example, for the survey agent I had with the users we had for the survey agent, which was taking the whole system and it was asking questions, it was actually not as 80%, it's correct. And but when it falls down really badly. So it just throws people off sometimes that people say something and when they don't get the answer, and if the agent still cannot understand that, it's just really, you don't want to read it, what they are saying, but yeah.
So one more question out there and then we'll break for lunch.
Yeah.
And also,
yeah, so the question was from the psychology side, how effective was it compared to the paper-based system? It was really effective. So we checked if the people felt that they were heard, that their problems were being heard, and we checked for engagement. And we also checked for if you would like to use it again or tell your other students or your friends to use it again. They'll say yes, but they will be more likely to get a human's opinion. So they were saying, yeah, I wouldn't like to use the paper, but if there was a human, I'd rather talk to the human. So that's one side. And the second question was, is there a effect of the uncanny valley? And uncanny valley is the thing that where you have this agent that looks like a human, but not exactly. So if there's something that throws people off, you tend to feel really kind of like discussed it in your like emotions, that you don't want to really talk to that or engage with that such an agent. So we did not have such a effect for this agent, but that said, we only used SFU students, and we used them from School of Interactive Arts, Computer Science. So these students were like really interested in such systems, and they were really like culturally it was really different. And that said, I had a professor from anthropology, and we were talking about having a language learning agent with this system that will teach the First Nations languages to the children. And when that professor first saw my agent, he was like, oh, I'm never going to talk to that person. So like there's a cultural difference, and like it changes from person to person, I guess. Thank you.
Okay, thank you so much. Fascinating.